A plant on your windowsill seems simple. It just sits there, absorbing sunlight. But its efficiency is baffling. When a photon of light, a single packet of energy, strikes a leaf, nearly every single time, that energy is captured and used. Classical physics struggles to explain this. The photon doesn't just hit one molecule and hope for the best. Instead, its wave function spreads out, exploring every possible pathway through the dense forest of chlorophyll molecules at once. This quantum superposition allows it to instantly find the most efficient route to the plant's reaction center, a phenomenon known as quantum coherence. It's less like a ball rolling down a hill and more like a wave collapsing on the perfect spot. This strange ability to exist in multiple states at once isn't exclusive to plants. Consider the European robin. Each year, it migrates thousands of miles with incredible accuracy. Its navigation tool is not in its beak or its brain, but in its eyes. It can literally see the Earth's magnetic field. The proposed mechanism is called the radical pair model. A photon enters the bird's retina and creates a pair of molecules, each with an electron whose spin is quantumly entangled with the other. The planet's weak magnetic field is just strong enough to alter how long these electrons remain entangled. The bird's brain interprets this quantum spin state as a pattern, a filter of light and dark overlaid on its normal vision, pointing the way north. Life's machinery also exploits the quantum world to defy classical expectations. Your body contains trillions of enzymes, proteins that accelerate chemical reactions. The old model was simple, a lock and a key. A molecule, the key, needs enough energy to climb over a barrier to fit into the enzyme's lock. But what if it doesn't have enough energy? Classically, nothing should happen. But at the quantum level, particles are also waves of probability. A proton doesn't have to go over the energy barrier, it can simply tunnel through it. It disappears from one side and reappears on the other, an impossible feat for a macroscopic object. This isn't a rare trick. Calculations show that for some essential biological reactions, without quantum tunneling, they would take longer than the current age of the universe to occur. Even your sense of smell might be a quantum detector. The standard theory says a molecule's scent is determined by its shape, fitting into a receptor in your nose. But this theory has holes. Molecules with nearly identical shapes can smell wildly different, like almonds and cyanide. An alternative idea, the vibration theory, suggests your nose doesn't just feel the shape, it hears the molecule's hum. Every chemical bond vibrates at a specific frequency. When an odorant molecule is in a receptor, an electron is poised to tunnel across it. This tunneling can only happen if the electron gives up an amount of energy that perfectly matches the molecule's vibrational frequency. Your brain registers this specific energy loss, this quantum event, as a smell. So, what does this all mean? We have plants using superposition, birds seeing entanglement, and enzymes relying on tunneling. These aren't isolated curiosities, they are foundational processes. For decades, the assumption in biology was that the cellular environment, warm, wet, chaotic, was far too noisy for delicate quantum states to survive. Any quantum coherence should break down almost instantly. And yet, it appears life has not only learned to survive this noise, but has evolved to harness it. It actively creates and maintains these quantum states to perform tasks more efficiently than any classical system could. This forces an unsettling reevaluation. Is life simply the result of classical chemistry and physics, or has it been a quantum phenomenon from the very beginning? The line we draw between the strange, probabilistic world of the quantum and our own solid biological reality may not exist at all.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.